computer, okay? The entire session gets typically recorded. So that I can share with you guys again, in case you miss it. So let's go ahead and get started. So again, I think I mentioned to you about it, so I can skip it. So, yep, teaching is one thing that gives me extreme happiness, okay? So what's this course about? You may be wondering. It's an in-depth course on AWS services. There are about 2,600 services, or actually more. So every week they add new services. So it's impossible to cover every single service, but we'll only cover whatever is needed for the specific certification we are targeting, called AWS Solutions Architect Associate. Okay, so but it's pretty in-depth course. So I'm very excited, and you will have a lot of fun. Trust me on that. Whether you learn or not, in my classes, fun is guaranteed. So that's what I always say. So understand the landscape of cloud architecture. You will be able to really appreciate it. And again, that's the certification we are targeting. It's not so in-depth. It's very generic certification. It gives you the breadth of knowledge across most of the AWS services, important AWS services, and then without going too much depth into it. Okay, that's why it's good for everybody in IT professional. So helps you understand all major AWS services. We'll be able to architect solutions as AWS services. Absolutely, you can claim yourself as a AWS architect or a cloud architect. And by the way, whatever you are learning here, they are not specific to, even though we learn all the AWS specific jargon, these concepts are not specific to AWS. The same concepts are there in Google Cloud Platform. The same concepts exist in Azure, Microsoft Azure. So all the public cloud providers, you'll be play with it. So yes, be relevant in this fast-paced tech industry. So you guys know how the tech industry is going. So it's pretty fast-paced. In fact, AWS is not a bleeding edge or cutting edge by any means. It's been there for last several years. So again, as I said, this is a lot of this gives you a lot of breadth, not so much on the depth. That's why this course is really good for everybody. Developers of any programming language, technical leads and designers, DevOps engineers and architects, solution and enterprise architects, management and leadership team, all the way up to the C-level. Okay, and anyone else who wants to learn, of course. Make sense? So you may be wondering, do I need any prior coding knowledge? No, you do not. You do not need coding knowledge at all. And everything related to this AWS will be taught here within this 1 month. So don't worry about it. And I'm not expecting you to have coded at least one time in your life. So don't worry about it. And this is not coding exercise. This is not a developer certification or anything. Okay. So I do not expect any prior knowledge whatsoever. So don't worry about it. Any prerequisites? That's why I put this one. So all I request you to bring to the course is just bring that can-do attitude, and I'll take care of everything else. Okay, we will do it together here. So you may be wondering, or maybe you already know, what exactly is cloud computing? So simply put, anything that's not running on your machine, pretty much you can say it's running in cloud. So let's say the best example that I always use is Gmail. So you check your Gmail, right? But you are not running an email server on your computer. It's running somewhere else, right? You are using it as a service there. So anything that's not running on your computer pretty much is is considered cloud. You guys have data. You have a Google Drive. You have probably what else? OneDrive, etc. And that's where you must be storing your photos and videos and all. Okay, you're not storing them in your computer. You are using someone else's computer resources. You're using someone else's storage resources. They are not stored on your machine. So it's that simple, essentially. So what we will be doing it today itself, probably 30 minutes from now, you will be able to spin a new server in the cloud. You will be able to provision a new server. Either you can call it a spin a new server, spin a new instance, they call it, or provisioning a new server, like as if you have your computer. So you will have your own computer in the cloud, not on your machine, but somewhere in your AWS infrastructure. You will have it 30 minutes from now. We'll be doing that exercise. Okay. And then within that, you will install a piece of software called Apache there, and then I'll show you, how to proceed there. So hang in there. Well, why do I want to use cloud? What are the advantages of cloud? All of you guys, or most of you guys, are working for these big organizations. Why do they want to go for cloud? Currently, they may be using their on-prem data centers. They have their own data centers. Data center is nothing but the cluster of servers. So a big building, within that, all the servers will be there. All the compute servers will be there, and then the corresponding data storage will get attached to that, like your computers. So your laptop has two major components. One is called compute, your processor and RAM, and the other one is storage. Your hard disk will be attached to that, right? Mm-hmm. So in your big organizations, they may have their own data center. So in the case of AWS or Google Cloud Platform or Microsoft Azure, these are the big three, we consider big three public cloud providers. So they eliminate you having a need to have a data center. So you do not need to have a data center anymore. So you do not maintain, you will not buy the servers and put your application code in the servers. You just focus on your business logic. Okay, you write the code, but go put that code somewhere else in the cloud on someone else's machine. Like Amazon will provide you that, or Google will provide you that, or Microsoft Azure will provide you that. That is what is called public cloud. Okay, why anybody wants to go for cloud anyway? What are the advantages of it? Let's say we heard some big names here, right? Freddie Mac. Why do they want to go for it? Well, definitely the cost. Cost is one of the biggest reasons why you want to go for cloud. You don't need to maintain your own servers, and that's not your business anyway. If it's a Freddie Mac, then their business is all around the finance, giving the loans to banks and all that stuff. They don't know how to maintain it in the best way possible. They maintain the servers. So give it to outsource to someone else. Those are public cloud providers. So the other advantage is infrastructure as code. Let's say big financial institution like Freddie Mac, they got a big project there, and they want to spin additional 100 new servers. So they have to put a requisition for 100 new servers. They have to buy the servers, set them up, put the networking and other components there. And then, so it takes It used to take anywhere from 1 month to 6 months. Trust me, it used to, a decade back. Okay. And nowadays you will be able to do it even within your on-prem data centers. You'll be able to do it probably in couple of weeks, I think, anywhere from few hours to couple of weeks. Okay. But with this public cloud like AWS, you will be able to spend thousands of instances or thousands of servers. You will be able to provision them within minutes. You can write your code. You write a piece of code and then execute that piece of code. That piece of code will go and provision thousands of instances within minutes. That's the beauty. That massive scale. And by the way, the reason I said cost is because massive economies of scale. It's because AWS is buying, or AWS, as a matter of fact, Microsoft Azure and Google too. So they are buying this hardware in a massive scale. So you can never bargain that price. Okay. So you are pretty much renting their compute resources, renting their servers for the time that you want. Let's say you want these 10 servers for, let's say, 1 week to run your application. Sure, you will be only paying for that 1 week. Pay as you go. That's one of the advantages. Okay, so every time you talk about cloud computing, you will hear this term called elasticity. So the beauty of elasticity, let's understand what elasticity means. Elasticity means it's like rubber. You can expand and collapse. So you can go from one server to 10,000 servers within minutes. And you can shrink back from 10,000 servers to 10 servers if things go wrong. Let's say you are starting a new business, and your startup company, you have no idea if it goes well or not. And if you go ahead and buy the servers for $500,000 or a couple of $1,000,000 and put everything together, infrastructure, what if things go south? What if things don't go as expected? What do you do? Right? So here in the case of public cloud, what you do is that you experiment in cloud. Pretty much. Do you guys know that Netflix is what? $500, $600 billion company? Netflix does not have a single server. Do you guys know that? They completely rely on AWS. Every single line of code, including their sandbox environments, QA environments, pre-prod environments, prod environments, everything, they have it in AWS. They didn't spend a dime on their servers. They're completely on it. And companies like Lyft, Uber, they do not have a single server anywhere. They are completely on public cloud. Okay. And recently, you guys know that what's the Pentagon wrote a check for $10 billion over 10 years. They signed contract with Microsoft Azure. So they are moving completely to Microsoft Azure. And that became a controversial, because of Donald Trump and all that stuff. So you guys know that. So almost this is the way to go. There is no doubt about it. There is no reason for you to have your own servers anymore, pretty much. Okay, you can safely rely on the cloud, and they are not only cheap. If you architect it right, I need to put that there is an asterisk. I should put it. You have to architect it right. You need to understand the concepts right. Then only it will be cheaper. Anyways, so another example that I wanted to give you regarding elasticity is, let's talk about the Best Buy like servers. Let's say bestbuy.com, typically for their usage patterns on a daily basis, they need about 10 servers. It's a hypothetical example. I just made it up, right? Let's say they need about 10 servers, but only couple of days, let's say on Black Friday and Cyber Monday, their website gets flooded with the requests. So on those two specific days, they need from 10 servers to 10,000 servers. Again, I made it up, right? So it's impossible to kind of add these many new servers that quickly and take it out. If you're managing everything on your own, you don't have to do any of that. Everything will be managed by your public cloud providers like AWS. Does it make sense? So always think about elasticity. You can grow and shrink in matter of seconds. And the other one is productivity. Well, you don't have to worry about racking, stacking, like an on-site data centers. You don't have to worry about any of that. You just write your code, you do what you are good at, and then have someone else handle it about the servers and the performance, of course. Okay, because these guys are good at that. These public cloud providers are extremely good at that. They manage, they continuously monitor the health of this hardware, and they continuously change it. You don't have to worry about it. They guarantee you that you're always running on the best of the breed hardware architectures. Make sense, guys? And security, yes. So it's interesting that I put security out there on the public cloud. So you may be thinking that maybe one of the reasons that you don't want to go for cloud is security. That's what you may be thinking. It's more secure if I have the data within my data center. Not really anymore. Okay. Can you make the hardware, or can you make the data more secure than Amazon and Microsoft? They follow all the industry standard. They just not only pass, they exceed the expectations of major industry security standards. They got all the certifications out there, and they manage every single hardware instance in an utmost secure way, all the way from the physical security to the data security to logical security. So they take care of it. I don't think we can do that good job with that. Okay, so you know what? I talk too much. Of course, it's reliability. This is where we'll spend a lot of time actually, reliability. So even if one data center is down, my application will not get impacted. We are going to architect that way. Even if one data center is down, okay, my application should not get impacted because mine is a critical business application, right? So those are the advantages of cloud. There are types of cloud. We will talk about that. But before that, I want to take, I don't want to talk for too much, for too long. So what we will do is quickly, before I get into, types of cloud and all. So what we will do is, let's all go together. Let's go here. Can you all go to aws.amazon.com/free? So if you want to do something in AWS, you need a free account. This account is free tier. Okay. You will be able to provision servers in AWS, specific servers, somewhat simpler servers. You'll be able to do it for free. Okay. And you can do it free for up to 1 year. They will let you do that. I will tell you throughout this, 1 month, I will tell you what is free, what is not. And hey, to learn, you need to spend some money. So how much? Well, I will tell you, it's not going to be more than $10. Even that, Amazon will give you back. So don't worry about it. Okay. So when you have to create this free account, and then when you create the free account, you have to give your credit card. Okay, please trust me and then give it. Don't worry about it. Create that and then enter your email ID, password, confirm password, and AWS account name. Choose a name for your account. You can change this name in your account settings after you sign up. Okay, something like home or personal, something. You will get 12 months of free tier access. There is something called free tier. In your servers, there is a free tier servers. Okay, so they are free for the whole year. And in the database, there is a free tier. The whole database is free for 1 year. Okay, so I will tell you throughout the process. And then, by the way, if you get charged for, there are some services that are not free within this 1 year. I will tell you what those services are, but still you have to provision them. There is something called application load balancer that is not free, but you still have to do it. Okay, because we want to learn it, right? We want to learn the concepts. So, but I will tell you a trick later. AWS, if you email them, if you open a ticket with Amazon saying, hey, I'm a developer, I'm experimenting it, they'll give you money back. That's their customer service is the best. So go ahead and do that for me.
Hello, Venkat.
Okay, guys, so we got the free account, so that's important. So now let's talk about the types of cloud. So let's spend a couple of minutes here, and then we'll go back again to the console. There is something called AWS Management Console. That's where all the fun happens. That's where you're logged in, and that's where you'll be able to provision these new servers, etc. Okay, so before we do any of that, let's talk about types of cloud. There are 3 types of cloud. One is called infrastructure as a service. So this is what we'll be dealing with mostly. So this is where you talk about the physical servers, your compute. You will go and provision a new server. Okay, you will attach a hard disk to that. Okay, and much more than that. So this is the lowest level. And you talk about the physical machines, virtual machines, RAM, storage, everything you talk about it. And this is where all the major public clouds, cloud companies excel at, like AWS, even Google Cloud Platform and Microsoft Azure, Oracle, IBM, they're all catching up. Okay. So infrastructure as a service is the lowest level in all the 3 types. And the next one is called platform as a service. Here, you don't care about the infrastructure. Someone else will worry about it. These cloud providers will worry about it. You write your piece of code based, according to some standards or according to some contract. And then you don't worry about what server it gets deployed on. So it will, auto-magically, it will get deployed somewhere on one of the servers. And then as the load increases, it will automatically scale to your needs, meaning it will add new servers based on your need. That's called platform as a service. So this is where, there are some concepts like a Google App Engine. Okay, Google App Engine is a good example of a platform as a service. Pretty much you don't have to worry about the servers there. Okay, and there is something called AWS Lambda. We will talk about it, probably 3rd, 4th week. But essentially, in platform as a service, you don't have to worry about it. You don't have to worry about infrastructure, but you have to worry about your platform. If it's a Java platform, you have to write code in a certain way, and if it's a Ruby platform, you have to write your code in a certain way. But once you code it, it just automatically gets deployed somewhere. And the last one is called software as a service. This is what we use it most often. Salesforce.com is the best example. Here, you don't worry about servers. You don't even worry about the platform also. I don't care whether it's written in Java or .NET or Ruby. I don't care. So I'm using it as an end consumer. Gmail is a perfect example. You don't care about the infrastructure. You don't care about the platform. You're using it as a pure service. Google Docs is another example. Make sense? So when you talk about cloud, be in a position to appreciate the difference between these three. And this is where we will spend, almost entire, 4 weeks. We will be spending here at the infrastructure as a service. We will spend some time at the platform as a service also. I will show you something called AWS Lambdas later. Beautiful serverless architecture. That's the real cutting edge. It's not here, but it's in the form of AWS Lambdas. I will talk about it towards the end. Make sense, guys? So the another one that we need to understand and be in a position to appreciate is this cloud deployment models. So how many deployment models are there? One is called public cloud. In the case of public cloud, you are completely provisioning your servers in the public cloud providers. So you don't worry about anything, no racking, no stacking, nothing. You somehow magically, click couple of buttons and then your server is ready. We will do that today. Public cloud. This is where your AWS, Google, and your Microsoft Azure come into picture. There is something else called hybrid cloud. Well, maybe you are not ready, your organization is not ready to go into public cloud yet. Okay, yours is a big financial institution, they are not ready. What they can do is, maybe they're not sold on security yet. Okay, maybe they have some compliance reasons why they want to keep the data within their data center. Sure, but they can run their web servers and application servers in the cloud. You see what I'm saying? They are mixing their own data center along with the public cloud. So they set up something called VPN tunnel between these two. They have their own data centers and they have their corresponding public cloud, and in between either they set up a direct link or VPN. Okay, so the hybrid cloud is where some of it will be in the public cloud and some will be in your own data center. Absolutely, you can go with that architecture if you have a strong reason. But understand, as an architect, what are the reasons behind that? Are there any reasons why you want to keep them in your data center? Maybe there are some good reasons, but just put it out there. And the other one is private cloud. Well, you guys are not ready for public cloud at all. You guys are, you can't put anything in public. So hybrid is also taken out completely. So you are giving your hosting services to someone else, completely dedicated hardware, and they will give you their own, racks. So there are some private cloud companies out there. Okay, so they will be giving you the physical servers, but they will provision for you. They will provision for you, and only for you. It's a dedicated hardware for you, and that's called private cloud. So still you don't have to maintain your on-prem. You can maintain it somewhere. They use it in their own data center, but you're paying them. But they will be purchasing the servers just exclusively for you. Okay, pretty much. Instead of putting in your own building, you're putting it somewhere. So pretty much that's your private cloud, and it's almost equivalent to your on-prem also. Okay, so what we will be dealing with is the public cloud. So this is where we'll install our web servers, application servers, database servers, and beyond, much more than that. So public cloud is a way to go. For all the new architectures, think about it. If you have any startups, small companies, medium companies, large companies, Netflix, $600 billion company, it's completely in public cloud. Okay. Any questions at this point? You can bring up some points, from your company, and if you want to share, absolutely, no worries. Let's make it conversational. Any thoughts? Is it something that you guys already know, right? Maybe.
Venkat,
Yes.
this is Gandhi. What is the difference in access level, public cloud and hybrid and private? Like if it is a public, is everyone has access to that, or how it completely different?
No.
The security restrictions.
Yep.
If it is a
So
private, what is the difference?
right. That's a very good point. So in the public cloud architecture also, there is a clear responsibility of what are your responsibilities versus what is AWS responsibilities. Okay. So still, even though, so essentially in public cloud, what happens is, let's say there is a physical server. Okay. Within the physical server, we are creating multiple virtual machines. We call them as virtual machines. So one physical server will be, there is a special software, we use it called hypervisor. I'll tell you in a couple of slides. But anyways, so you are making this physical server, you are dividing this into multiple virtual machines. And then you may be having your virtual machine on the same physical server, and I'm sitting right next to you. This is like a shared apartment. Within an apartment, you are a tenant there and I am a tenant there. Does it make sense?
Yeah,
But but there is a clear security boundary. I can't access your data, you can't access my data. I have my own dedicated ports, you have your own dedicated ports. Security is everywhere. And as far as the physical security is concerned, AWS will completely handle that. Meaning you will not be able to enter the building. That's completely AWS property, and they will take care of physical security, and they will absolutely make sure that CC cameras are everywhere, and they will absolutely make sure that appropriate secured principles are followed within their own security guards and all. They will take care of that. But as a responsibility, you have been given a virtual machine, and it is your responsibility to make that secure. They give you a piece of hardware, and then you have to make it secure. If you leave that port open for anyone to come in, then anyone can come in. You can't blame AWS for that. Does it make sense? It's a responsibility segregation. AWS is responsible for physical security, and they will take care of operating system level, but you have to worry about your other things. Does it make sense?
Yeah. Thank you.
Yep. Oh, that's a good question, actually. Okay. So AWS is undoubtedly the most popular cloud provider in the world. It's the number one. Okay. And they have more than 2,500 services. And it's a loud and clear leader in the public cloud provider. If you really look at it, this is called a Magic Quadrant. Okay, this is provided by a company called Gartner. Not only in the public cloud, but they just go, and then in various industries, who are all the leaders. Okay, look at this one. These are the leaders. Amazon Web Services is being the number one. In fact, Amazon Web Services did not have a competitor for almost good 6-7 years. Do you know that? And Microsoft is kind of picking up, and it's it's a decent gap. Microsoft is very close in completeness of vision perspective, but ability to execute, Amazon is here. Even completeness of vision, Amazon is here. Microsoft is here. Google is it's also considered the leader here in this quadrant. Okay. It has a very limited market share, but Google is out there. And then these other companies, they call it niche players, Alibaba Cloud, Oracle, IBM, these guys are slowly picking up. They're trying their best. I think that, Oracle is really investing also. But what I wanted to mention here is that AWS is absolute number one in this game. So, and obviously, you want to join the gang. Okay, and then when you talk about the certifications, AWS certifications, there are a couple of certifications out there. So one is called the most basic certificate. This is called a Cloud Practitioner. This is the easiest certification out there. This one you can take it pretty much anyone who has any knowledge on AWS all the way to the C level. Anyone can take it, get some knowledge on AWS cloud. Okay, and this is the certification that we are targeting here. AWS AWS Certified Solutions Architect Associate. This is an architect level certification, and it gives you the breadth of knowledge, but not so much on super depth. So any of the developer certification, if you are a developer, even if you are a developer, I would say first go for this certification, because this gives you a lot of breadth. You'll understand most of the important services out there as an architect, and then go for this AWS developer certification. It goes into the depth on certain concepts. And there is for all the SysOps guys, you can go for the SysOps administrator. And there are some 2 professional certifications called AWS Certified Solutions Architect Professional. This is undoubtedly the most respected certification out there. A couple of years back, I think there are only 3,000 people in the world, I was told. So this is the professional one. I will not recommend until you pass this one. You can actually take it. You're allowed to take it, but I will not recommend it. This is the toughest exam out there. Any questions on that? Okay. So, my 4-week course outline: when do we meet, how do we meet, where to check for more details. So you only need to know one thing, guys. My website, which is nextep.training. This is my website. It's not .com, by the way, .training. NEXTEP, nextstep.training. Okay. So this one, this is where you will see, my blogs, the whole AWS training, all of my previous videos. This is where I'll post my homework. Okay. Training overview, how to join. So how to join the Zoom, prerequisite, all of your, we'll work on, decent Unix commands, all the commands I throw out there, so that, you can go and practice them any times. And my previous, all the Java training videos, I made them public. I open sourced them. All of them are here. If you or any of your friends, need it, you can go watch them. They're all free. So that's about it. We typically meet, Saturday and Sunday, both the days, 8 to 12, typically 4 hours. Today is not going to be 4 hours. Today is going to be pretty, probably we'll meet for another 1 hour or so. And today and tomorrow, we'll keep it light. And then from next week onwards, we'll go in full swing. Okay. Okay. So if you guys don't have any questions, now we will spend time on the real stuff, real AWS. Okay. Do you guys have any questions at this point? Okay. So before we talk about anything more in AWS, we need to understand this concept called AWS Global Infrastructure. The reason AWS is in this position, leader, the number one leader in this whole public cloud, is because what they did is they brought the entire globe into one place. Pretty much, they made this global village possible. So this is the entire globe. You know, they went ahead and built the data centers across the globe. Not in every single country, obviously, but across the globe, pretty much. If you really look at the US here, right? So they have a couple of data centers on the east side, and they have a couple of data centers on the west side. Okay, these are called regions. I'll talk about it in a second. But at the high level, you can say that there are a couple of data centers on the east side, there are a couple in the west side, and there's one for government cloud. There's one on the east side, the other one on the west side. So they distributed their data centers across the globe, okay, with so much strategically. It works not just for now, it's 100 years down the line also. Pretty much they have it every nook and corner, they have it. See, in this the South America, they have it in one in Brazil, and there are few centers in Europe. They have one in Mumbai, one in Singapore, and they have one in Australia. So they went and built these data centers, okay, and now they connected all of them with their own internet backbone. They have the fiber optic lines. Pretty much it's going across all of them, connected together, okay. So they have they went to the really next level and then built it. They spent billions of dollars on this one, right? So this is the main brain behind the whole AWS. So in this global infrastructure, there are two concepts here. One is called region. So if you really look at here, right? So each one of them is called region. So they divided the globe into multiple geographical region. They called all of this area as US East. This area, they called it US West. So in US East, again, we have two data centers, US East 1A and US East 2A. US East 1 and US East 2, sorry. So they have one in Northern Virginia, in Ashburn area, and they have another one in Ohio. So Northern Virginia is the first data center in the entire AWS area. It was built back in 2006, I believe. Okay, so we have one in Northern Virginia, one in Ohio, and on the west side we have one in California, and the another one in Oregon. The third one is a government cloud. That's for government organizations. Okay, so what they did is they built, they call this region. You need to understand these terms, okay, for the both exam perspective and if you really want to understand and appreciate the whole AWS, right? So you need to understand this concept called region. A region is nothing but a cluster of data centers. It's not one data center, guys. There are several data centers within that geographical region. Okay, so Northern Virginia is one of them, Ohio, US East Northern Virginia, US East Ohio, and US West Northern California, and US West Oregon. There are 4 regions for us in the United States. And within the region, there are multiple data centers, and each one of them is called availability zone. They don't call it data center itself, they call it availability zone. The reason is, this availability zone may not be one data center again. It could be multiple physical data centers, but they combine together. They're asking us to view this as a single data center, as a logical data center, and that's called availability zone. So one region will have several availability zones. So the beautiful architecture here is that these availability zones are about 100 kilometers apart from each other. let's say in Ohio region. So let's say they have one in Cleveland, the other one in somewhere nearby, within 100 kilometers range. So they're not too far, but at the same time, they are far enough so that natural calamities in one area will not affect the second one. Let's say there is a power cut in Cleveland, it will not affect the another availability zone within let's say, I know Cincinnati is too far, that's probably a bad example, but you get what I'm saying. Yeah, let's say in my hypothetical example, cleveland and um, Cleveland and what's the other one, Cincinnati, or let's say Ashburn and somewhere Hendon, right? So you can say both of them are having two availability zones within 100 kilometers range. That's how they built it. So if there is a lightning in one area, it's possible that the other availability zone is fully healthy. The reason is, when you spin your new servers, you want to make sure that you distribute them across all these availability zones. When you are building a web server, for example, you want to build them one in one data center, the other one in another data center, and then you want to link them up so that if there is a God forbid, lightning in Ruston or somewhere in that area, right? So the other data center will not be available. That's the idea here. So as an architect, you need to understand this concept of availability and scalability. Availability meaning out of 365 days, okay, round the clock you are expected to provide your service, right? Let's say amazon.com, let's say it's down for, let's say, 5 minutes in the entire month. Actually, can they afford 5 minutes of downtime within the month? Can they afford? In all fairness, no, they cannot afford. But let's say there are 5 minutes down in the entire month. So we'll call them, they are available for 99.8% of the time. So 99.9% of that's their availability. Meaning how much time are they available? The remaining time is downtime. Okay, so you need to you have to architect in such a way that your application is all the time available, almost all the time available. And you want to do it in such a way that even if one availability zone is down, you want to have your application up and running in a healthy fashion by distributing across the availability zones. Okay, so and another important point is that all these availability zones in an AWS region are interconnected with high bandwidth, low latency networking. These are all interconnected. Okay, so you'll be able to send the data between the availability zones. In fact, you can have these servers together, one of them in one availability zone and the other one in a second availability zone, and they'll be able to talk to each other, etc. But they are far enough that they are isolated and protected from natural calamities. I want you to understand that. Okay. Any questions there? The reason it's so important is because now when we spin or when we provision our virtual machine right now, 5 minutes down the line, we are going to pick a region. Within a region, we are going to pick an availability zone. Within a specific availability zone, we are going to spin a new instance. Okay. Region, availability zone, we got it. Now, let's go ahead and, enough talking. So let's go ahead and spin a new instance in AWS. Okay. So before we do that, let's talk for 1 minute. So our physical machine, our laptop, our server right? How does it look like? What's the architecture like? Well, you have your hardware. On top of hardware, you have an operating system. On top of your operating system, you have applications, Microsoft Word, PowerPoint, your Apache, your Tomcat, your applications. Make sense, guys? And each one is listening. Probably Apache is running on port 80. Your Tomcat app server is listening on port 8080, like that. This is typical, right? And you have a dedicated hardware here. It's completely dedicated. This is one machine. This is for you. This is your machine. But this is not what you're going to do in the cloud. Well, if you want to, you can get the complete dedicated host also, but it costs fortune, and that's not a smart way of going. Rather, there is a concept called virtualization. You want to virtualize this one. So let's look at it, how the infrastructure look like. So you still have hardware, and on top of it, you have your operating system. They call it host operating system, maybe Unix-like operating system. So on top of it, what you do is it's a big hardware here, big piece of hardware here, okay? And on top of it, you have a host operating system, and on top of it, you will install something called hypervisor. So hypervisor is a piece of software, okay? What it does is, it using a hypervisor, the physical hardware can be broken into multiple virtual machines. So it gives you the feeling that this is my complete hardware. This is my computer. That gives you that feeling. It's like in an apartment, right? Within an apartment, you'll get the feeling that this is your complete home, even though you're sharing your wall with the neighbor, with your neighbor. So this hypervisor will give you that feeling. Actually, this is what you guys are doing right now in your office, guys. When you're logged in to your virtual machines, it's not a physical machine, it's a virtual machine, even if you're not on the public cloud, okay? So on top of that hypervisor, you can install a virtual machine, and within virtual machine, you can have a separate operating system. So this is as, look at it, there is one operating system. This is called host operating system. So one physical machine, I'm breaking that into multiple virtual machines, and each virtual machine is having their own operating system. That's the beauty there. And it's all happening in a one single machine, one physical machine. So on top of the guest operating system, we have a couple of apps. Let's say your Apache and Tomcat running. You can have a second virtual machine. So earlier Gandhi was asking the security here, right? So this may be Gandhi's virtual machine, and this may be my virtual machine. We both happen to be on the same physical machine here, guys. But it doesn't matter. It gives me the feeling that I'm all alone. This is all mine. But it's not. A slice, a piece of hardware is what given. So let's say this is a 6-core CPU, 6 physical cores. They will divide that 6 physical cores into, let's say, 6 times 4, 24 virtual CPUs. Hypervisor can do that, and you can pretty much install 24 virtual machines, and each having one virtual CPU. If that makes sense. Make sense? And each one of them, you are getting your own, pretty much your own apartment within the complete apartment complex. This is your own home. You can do anything. You can get your own plumbing. I mean, well, the underlying physical hardware is same. If this physical hardware fails, yes, everybody gets affected. There's no doubt about it. Okay, but all the network components are also same, because they're attached at the hardware level. But you'll be completely freed to use your own ports, your own applications. Pretty much you are on your own. So this is what we are going to do. We are going to provision a new virtual machine. We are going to get a slice of hardware, and then with your free account, you will get a free tier virtual machine for 1 year. You can have this virtual machine running it and install it, do whatever you want to do it for 1 year. You don't have to pay a dime. But you can't spin a big virtual machines with 6 cores, 4 cores and all. No, they will give you, there's something called free tier eligible. That's 1 core, 1 vCPU. They call it 1 virtual CPU. Okay, you can do that, and that's enough. And 1 gig RAM will be given to you, and you can attach a hard disk. You can attach an SSD drive to that. You have your compute and SSD. Like in your computer, you have your processor, RAM, and you have your storage, right? Your hard disk. So we can do that. And let's go ahead and provision this virtual machine. And after this, let's log into this virtual machine. And then let's do some fun stuff there. So what we will do is we will provision a virtual machine with Linux operating system there. And that too, we will use Amazon's own Linux. Linux is an open source operating system, as you guys know. There are multiple flavors there: Red Hat Linux and Ubuntu and CentOS. A lot of flavors, right? So one of them is Amazon's own Linux. So we will install Amazon Linux operating system. So we are going to provision a new virtual machine with Amazon's Linux operating system. We will get it. And then we will install one application called Apache. Apache is a HTTP server or a web server. So if you want a website, obviously you need a web server. Okay, this web server will give you HTML pages. Let's say index.html. That's your, you're asking for index.html. Give me myhome.html. It will give you that. You can write your HTML there and then it will give you back. Okay. Typically this Apache will listen on port 80. Let's go ahead and do that. Let's provision a virtual machine in AWS. Let's go dive into that. Make sense, guys? Any questions so far? So this is what we will do. We will provision a virtual machine, EC2 instance. We call it EC2, Elastic Compute Cloud. That is one Amazon service, AWS service. Okay. We will, since this is a Linux machine, we will SSH into that newly created virtual machine. SSHing into it is nothing but you're trying to log into that. And after you log in, you will install Apache server and then access the home page from your browser. It's that simple. All of this, you can do it within, I know today you will take time, guys, but you will do so many within this 1 month, and you will be in a position to do this within probably 3 minutes. Okay, so let me show you without delay. Let's go ahead and I'm logged in, sign into the console. Oh, Venkatu. Okay, so I'm logged in. So when you log in here, guys, sign into the console. See here, root user and IAM user. So root user is nothing but the main account that you created with your email ID. It's not a good practice to use your root account, because with root account, you can do everything. That's an administrative account, but we will start with the root user. Later on, I will show you how to create your users, within your organization. I will show you that later, but let's go ahead and log in. You can also log in. Okay, this is how it looks. AWS Management Console. This is where you will be able to provision your new instance. Okay, new virtual machine. Well, virtual machine is a compute service. Compute service. I hope you understand when I say compute service. It's nothing but your CPU and RAM and everything. That's the compute service, right? So There are multiple services here, look at all the services here. So they categorize these services. EC2 stands for Elastic Compute Cloud. This comes under your compute services. This is your compute, this is your containers, this is your storage, this is your database, migration and transfer, networking and content delivery, developer tools, customer enablement, robotics, analytics, machine learning, media services, management. Look at it, how many services they have. These many services, almost for everybody. For IoT guys, you have services. Big data guys, we have services. IAM guys, we have your services. Security guys, yeah, absolutely, we have your services. Everyone is covered here. Okay. Now, either you can go to all services, click on EC2, or you can directly click on EC2. So EC2 means Elastic Compute Cloud. That's the first service we will be learning about. So here it's telling you how many running instances are there. Running instances meaning how many virtual machines that you have it. And these virtual machines called EC2 instances. So I can go to services, click on EC2, and let's look at this dashboard. I don't have any EC2 instances running here. So click on this running instances, or you can click on launch instance. To get started, launch an Amazon EC2 instance, which is virtual server in the cloud. We are creating a virtual server in the cloud. Click on launch instance and launch instance. Now, it is asking you, hey, what operating system do you want? Okay, we are saying that we want Amazon Linux to AMI. And first of all, select this guy, this checkbox here, free tier only. We do not want to pay anything. I want only free tier. Then the options will be less. And then here almost all the time we can take the first one, Amazon Linux to AMI. AMI stands for Amazon Machine Image. We will talk about that later. But essentially, what we are saying here is that I want to create a new virtual machine using Amazon Linux operating system. So select it, and it's a 64-bit. Select this guy. And then here you are selecting what instance type do you want to do it. There are multiple instance types. Some of them are very expensive. Okay, this general purpose. T2 micro, T2.micro, this is a free tier eligible. Okay, so we want to take free tier only. And look at this one. This is one virtual CPU, guys, and it's 1 gig RAM. So we are installing a computer in the cloud right now that has 1 gig RAM and one vCPU. That's not a physical CPU, that's a virtual CPU. As I told you, if you bought, let's say, a computer with that's 6 physical cores, you can virtualize it using your hypervisor or your VMware softwares. You can virtualize it and create multiple virtual machines. And here we have one CPU, one vCPU. So select this one and instance store, EBS only. I will talk about what an EBS is. This is nothing but you're attaching a hard disk drive to that. Just select this guy, T2 micro. It's a type, T2 micro. It's a type, meaning it's a general purpose computer. You are doing it on the cloud. Click on the next configure instance details. Let's spend a minute here. How many instances do you want to create? 1. Okay. Purchasing option. We will talk about this spot instances later. And then look at this network. Oh, by the way, one thing that I missed earlier was I wanted to show you. We talked about region and availability zones, right? Okay. This virtual machine, where am I? Where am I provisioning? Look at this one here, guys. Okay. See, I'm in Ohio region. By default, it selected me Ohio region based on my location. What did you guys get it? Are you guys also doing with me? So this is Ohio region, but let's say if I want to do it in Northern Virginia, you can select it. You know what? I'll select Northern Virginia, and then I'll come back, go to services, go to EC2. Now my virtual machine will be in Northern Virginia. Anyway, I started it, but I did not create that one, right? So launch instance, free tier only, select the first one here, and then general purpose one CPU is enough, instance details. Okay, guys, my EC2 instance will be created in Northern Virginia, meaning my virtual machine will be created in Northern Virginia. And then look at here, there's something called subnet. We will talk more about the subnet later, but these many availability zones are there, these many. So Northern Virginia region is called US-East-1. That is the code for the region, okay? And these many availability zones are there. So each availability zone is a data center, and all these availability zones are distributed across Northern Virginia within 100 kilometers range, so that you will be able to distribute your virtual machines across all of them, so that even if one availability zone is down for whatever the natural calamities, your business is not impacted. That's how an architect should think like. Okay. I'll go ahead and do it US East 1A. You don't need to select also. I'm selecting one of the availability zones. You don't need to select it. By default, it will select. Okay. 1A meaning it could be Ashburn. 1C meaning maybe Reston. 1D meaning it's nearby cities. Any other nearby cities in Northern Virginia? Okay. So you can select any availability zones, it doesn't matter. And then auto assign public IP. Yes, please assign public IP. Yes, it's enabled. So when you do a EC2 instance, when you provision a virtual machine, please give me a public IP is what you're saying. Yes, I need it. And placement group, all of this one, you have no idea, and don't worry about any of this one. Tenancy, all of this, don't worry about it. Okay. Oh, see this one, probably tenancy is what I will maybe spend a minute here. Run a shared hardware instance. You are running on a shared hardware instance. If you want to select a dedicated instance, it will cost you a lot of money. Either run a dedicated instance or a dedicated host. Lost this instance on a dedicated host, it costs you a fortune. So do not do that. Please select your run a shared hardware instance, and you don't know any of this one, just leave everything as is. Just leave everything as is. Do not have to select anything. Click on storage, and now you selected your compute service, meaning you have one virtual CPU, 1 gig RAM. You have your compute, and now you are attaching hard disk to that, right? So you are attaching 8 gig SSD, general purpose SSD. You are attaching an SSD, 8 gig SSD to your virtual machine. Is that enough? Enough? Absolutely. And do you want to encrypt your
Venkat?
Yes.
Just 1 minute. Can you go back to the configure instance?
Absolutely. Go ahead.
Oops. I'm trying to do that.
Okay. What do you want to do?
Yeah, I'm trying. I just want to look at the network, and then you said like create new VPC, right?
No, I didn't say that. I didn't say that. You don't have to select anything here. We will talk about this VPC concept, the most important concept later. But you are doing it in a default VPC. You do not have to select anything. All I was saying is that in the subnet, this is where you will select which availability zone do you want to put it in. Where do you want to put this this
I can like just say, can
virtual
I
machine.
just say default subnet in any availability zone, or do I have to like pick one?
You don't need to pick. You don't need to pick. I wanted to show you what I'm saying here. See here, Northern Virginia. So my machine is going to be installed in Northern Virginia. In Northern Virginia, there are 6 availability zones. I wanted to show you that.
Oh,
That's all I'm saying. You
okay.
can pick any of them, or you don't need to pick. It will automatically pick. No preference. It will default subnet in any availability zone. Make sense?
Yeah. Okay.
And add storage. I'm attaching 8 gig storage and the tags. So tags are just, you're putting labels to your virtual machines, or any services as a matter of fact, any resources as a matter of fact. I can say it's a key value pair. Tags are nothing but, I can say name. Let's say this is my web server, right? I'll call it as a web server 1. Sure. And I can add a new tag. Let's say department. I'm provisioning this one for finance department, let's say. Yeah. Or HR department. This web server is for HR. Make sense, guys? Just I'm putting some labels there, that's all. These labels are important later on to look at your cost. Once you get the big bill from AWS, then you have to be able to say that, hey, what's the bill for IT? What's the bill for HR? What's the bill for finance department, etc. These tags are useful for that. Next, click on configure security group. So security group is nothing but a virtual firewall. This is where who can talk to who, what ports can be open on this particular machine. So you are creating this virtual machine, right? And later on, you are going to install an Apache right here. So what port do you want to open to who? That is your security group. Security group is nothing but a virtual firewall. Okay. At this point, do you guys know what port do you use it if you want to log into your Unix machine, guys? How do you log into your Unix machines or Linux machines in your office today? You use PuTTY, right? And when you use PuTTY, do you know what you use it? You use SSH, port number 22. Do you guys know that? No? Okay, so you use a port called SSH, secured shell, and then it's a port number 22. This is what will help you log into your machine. Okay, so I'm creating a new security group. I'll call this as a web server security group. Okay, I'll give the same description. And then what I'm saying here is that SSH is the protocol. TCP is a protocol, and number 22. Port number 22, I'm opening port 22 to everyone in the world. O.O.O.O/O meaning the entire world. So please open port 22 to entire world is what I'm saying. Why? Well, I need to be able to log into this machine. Ideally, you don't want to, later on I will tell you that you don't want to open port 22 to the entire world. You want to open it only to your machine. I will show you that later. Don't worry about it for now. It's only the first class. Review and launch. Okay, you understand everything. So that's it. You just briefly review it, click on launch. And now let's spend a minute here. Once you have this virtual machine, how do we log into this virtual machine? Well, it's not a password-based authentication. It's rather a key-based authentication, a public-private key pair. You have to have a private key to log into that machine. So it is not a password-based authentication, guys. It's a key-based authentication. So here it is saying select an existing key pair or create a new key pair. I don't have anything, so I'll create a new key pair. Okay, what it does behind the scenes is that my first key pair, what it does is it will generate private and public key pair. So if you guys don't know, there are a couple of ways you can log into your machine. One is password-based authentication. You give your username and password, and you'll be able to log into the machine. The second way is public and private key pair. So now, right now, once you click on this download key pair, it created a public and private key pair. It gave you the private key and it put the public key. It will put the public key part into your virtual machine so that you'll be able to log into that virtual machine using this private key pair. Click on launch instance. I hope it makes sense. And even if it does not make sense right now, it will make sense in a couple of days. Okay, because you're going to be doing it hundreds of these instances. So don't worry about it. So click on view instances. What did we just do? We just created a new virtual machine in AWS Cloud. It'll be done in less than 1 minute. In less than 1 minute, you have your own server in the cloud, guys. You have your own server in the cloud. Yes. And please keep this private key. And if you wonder, this is how your private key looks like. Okay. And the corresponding public key has been placed already in the virtual machine. So when you use this private key, it will make sure your private key is matched with your public key, and then it will let you log into your virtual machine. Make sense? So how do I log into this one? I have a new machine. How do I log in? How do you guys log in your office? Using Putty, right? Well, Putty is one way to do it, and that's one of the main ways to do it. But for now, since it's the first day, I will show you an easier way without you need the Putty. Okay, click on this. You can use something called browser-based SSH. So Amazon will give you that. See here, select this virtual machine, click on Actions, and then click on Connect. And then select this third one, EC2 Instance Connect. See, third one. And what is the username? Who do you want to log into this virtual machine? It is automatically giving you a username, EC2-user. Always you log in as this particular user. Just click on Connect. Now, what are you doing? You are connecting to the remote virtual machine that you just provisioned. You are logged in already. You are in that machine now. This is like your Putty session, but it's a simpler. You don't need Putty. Okay. There are some downsides to it, but we'll talk about that later. Don't worry about it. For now, I want you to successfully log into this newly created virtual machine. This is your virtual machine, guys. This is your machine. That's your computer in the cloud in AWS. So present working directory, you are in /home/EC2user. This is my Linux operating system, the to Amazon Linux operating system, right? So what I can do is I can check if there are any operating system updates there. Do you guys know sudo? Sudo means you are doing as super user. Okay, sudo su. If you do that, then you are elevating the privileges as a root. Now you are logged in as a root. Now see this one, your username is changed to root. Use this command, and all these commands you do not need to by heart. Go to my website and you'll AWS training and Unix commands. See this one. To log into Amazon EC2 from your Mac terminal. If you have a Mac, you can use it from Mac terminal. This is what we are doing it. We're switching to super user after logging in. Okay, I am now super user. Now I want to see, what I want to do is, I want to do a yum update. I want to update my operating system with any security patches or anything. Let's see if there are any yum update. Okay, it's giving me some updates. Looks like there are some kernel updates, AWS CLI update. All of these looks like these softwares. These are important, operating system level updates. It's asking me to install. Yes, please install. In our virtual machine in cloud, this is our server. We are doing an operating system update, yum update. That's what it does. Make sense? You guys want to do that in parallel? Let's go ahead and do that. Okay, my operating system has been patched, updated fully, very, very well. This is my Linux machine in cloud. That's all. I know we wanted to install an Apache software there. Apache is a web server. We want to install it here. Okay, we will do that. But first, let's make sure you are all up to here. Let's take time and make sure you're all settled. Okay, guys. So whoever has success connecting to it using browser-based SSH, right? So what we'll do is I will show you one more way. So install this software called Putty. Okay, Putty. This is one more way to connect to your machine. One way is browser-based SSH. This is another way. So click on this. This is my 64-bit. So click on this guy and install it. I already have it. But go ahead and install it. So after that, with the Putty, you will get a software called Putty Gen. Open this Putty Gen. So remember I told you, if you want to log into your virtual machine, you do that two ways, typically. Username and password. The other one is public and private key pair. So Amazon chose public and private key based authentication. Okay, so it gave you a private key earlier. You downloaded the private key. Now, using that private key, how can you log into your machine, right? So that's what I wanted to show you. So first is, if it's a Windows machine, when you downloaded the private key earlier, here you downloaded this guy, my first key pair. The format is PM format, PEM format. So Putty does not accept this format. Putty does another format called PPK. So let's transform this PM file into PPK format. So what you do is click on this load your file. So go to downloads and then select here all files and then go to my first key pair, whatever your PM file is. Successfully imported foreign key. Very good. So now it was able to import your PM file into this. Now what we will do is click on save private key. Are you sure you want to save it? Yes, I want to save it. And then here, I'll use the same name, my first key, my first private key, .ppk. See this one? Now we changed it, you can close it. Now we changed it from PM to PPK. So if you look at it, this is a PM file. And now we changed it using Putty Gen software. Putty Gen is used to, you can generate an SSH key pair, or if you have a private key in PM format, you can load that and save your private key as PPK file. This is my PPK. Make sense, guys? Now what we'll do is, I hope that makes sense. It's a first step is to transform the PM to, PPK. And the second step is now open your Patti's software, go to connection, SSH, auth, meaning authentication. Here, give your private key file, browse, go to my first private key. So you gave your private key there. Now go to session, and here you have to give your host name, username. Your username is always ec2-user at, and you have to give your host name, complete host name, your username at host name, port is 22. Yes. How do I get my host name? Well, this is how you get your host name. Go to your machine here and see here, public DNS. This is your publicly available DNS name, guys. This is your public DNS. So go here, paste it. So what you are saying here is that I want to log into this machine. This is your machine name, DNS name, right? I want to log into this machine as EC2 user at this machine, port 22, and this is my private key here. Make sense? Click on open. It will ask you, are you sure you want to accept it? Yes, please. That's it. You're logged into your machine now. See this? This is your private IP 172. This is your private IP. See this one? 172.31.90.107. See this one? It matched. 172.31.90.107. Make sense? Now you can do the same thing. Sudo su yum update. One more time you can do it. But there's nothing to update because you just updated it. If you want to install any software, you can do it. Yum install, let's say, Apache HTTPD. Yum install HTTPD. That's how you install Apache, by the way, if you want to do it. But this is a second way of connecting it. Please do that for me.
Venkat?
Yes.
Meghna here. Can you repeat what do you do to transform that PEM to PPK?
PP. Yep, absolutely. Yeah. Absolutely. So
before that, Venkat, I have a question.
Mm-hmm.
I didn't download that file. Where can I download right now? How can I download?
Which one? Private key?
Yeah.
Private key, earlier you would have downloaded it already as part of this machine. You cannot download your PPK file, PM file, your private key file again. You cannot do that. You can only do it once.
Okay.
By generating it.
Yeah, I have created an instance. Let me look, whether the file is downloaded.
Yep. You may have done it.
Venkat?
Check it in download folder. Yes.
Yeah, sure.
So I'm at connect to your instance. So the standalone SSH client.
Okay.
But
standalone SSH? No. Yeah. What's your goal? You want to do it?
So now I got the web server. It's running. And I have like couple of options: launch instance, connect, or actions. I had to go for actions, right?
Yep.
Actions and connect.
Yep. And the third one. This is a browser-based SSH connection.
No, means I have like connect, get Windows password, create template from instance. So I'm going for connect.
Where? Oh, sorry.
From actions.
1 second. Let's make sure we are both speaking the same language. Okay.
Okay. So I'm trying to share. So